Hello everyone, welcome to Grad Bunker. In this video, we are going to solve three different problems. Let's start. In the first problem, it says how many two-digit positive integers are there such that the product of the two digits is 24. To solve this type of problem, we need to understand a method. It's called U2 factorization. In this method, we draw a U, and in this U shape icon we will put multiplication as sign so that we will have two different values that are multiplied together and make a value. Like for example 4, we can choose two values to multiply that to make it 4, like 1 multiplied by 4 is 4, 2 multiplied by 2 is 4. So these are two different values we are going to put here. So for example, if we put a n1 and n2, it gives our capital N, the desired value. Similarly, n3, n4 and n5, n6 and n7, n8 and so on. And we will do this till the difference of these two values are close to 0, or in that case the minimum value. Here on the left side we have n1, n3, n5, n7, the odd values, and these values will chronologically be greater, and on the other side, on the right side, we have n2, n4, n6, and these values will chronologically be lesser value than the previous one. So here we have in this question the two digit value 24. So let's utilize it in our U2 factorization. So we can start with 1 and 24. These two values multiplied and it gives us 24. The value 1 we put there, below that we can put 2, and on the other side we can put 12. It also makes 24. In this way, from the left side the values will increase, and on the right side the values will decrease. So if we do this, we can get 3 multiplied by 8, which is 24, and then 4 multiplied by 6, also 24. Now if we look at it, after putting 4, we can use 6 multiplied by 4. As we can see that 4 multiplied by 6 and 6 multiplied by 4 are the similar, and it becomes a repeated, so we will stop it from there. Also, the difference between 4 and 6 is close to is actually 2, and it's close to 0, so we'll stop it from here. Now we will see that how many type of multiplication can be done to make it 24, and these all values are positive integers. So we have 1, 2, 3 and 4, so the answer is 4. There are 4 types of two-digit positive integers, so that their multiplication, the multiplied value, becomes 24. Here the answer is 4, and that's our answer. Now in the next question, it says if b and y represent real numbers for which y exponential to 3 is equal minus b, which of the following statements could be true? Here are options are Roman 1, Roman 2 and Roman 3. Here Roman 1 is b is greater than 0, and then b is equal to 0 or b less than 0. And we have our options: A none, B 1 only, C 2 only, D 3 only, or E 1, 2, 3, all are true. Now to start this solution, we have to understand that what is squared value. If we put y square, that means y multiplied by y, and this can be done either two positive values that multiplied that gives us positive value, or two negative values which also gives us positive values. We all know that the squared value is always positive. What if we have the cube value, y to the power 3? So here in this case, y multiplied by y multiplied by y, And this also has two conditions: either all are positive, it gives us positive value, either all negative, and this gives us negative value. So in the right hand side we have minus b. Now we have to consider that negative value is already here, but we don't know about b. It could be either positive or negative. Now if we take y equals positive value, then y to the power 3, it gives us positive value. Now in that case b should be negative value, so that the negative value of b and the negative sign will make it positive on the right side. So here b less than 0 is true. Now if we take y equals negative value, then y cube equals negative. In this case b becomes positive. So b is greater than 0, that's also true. If we take y equals 0, then y cube equals 0, and this is obviously b equals 0. As the question says, b and y represent the real numbers, so we can take positive, negative, 0, all type of values here. So the answer is E. 1, 2 and 3 all are true in that case. In our last problem, it's an algebraic problem. It says the function of 1 equals 2, and the function says that if function of n is equal function of n minus 1 minus half is true for all the integers where n is greater than 1, then function of 1 1 will be what? Our options are 49, 50, 51, 52 and 53. Now to solve this, if we put according to the function that if n equals 2, then function of 2 becomes function of a2 minus 1 plus half, which gives us 2 plus 0.5. If n equals 3, then gives us 2 plus 0.5 plus 0.5. If n equals 4, then gives us 2 plus 0.5, 0.5 and 0.5. Three values. Now if we look closely here, we see a pattern. In the first term, it says when n equals 2, we have the value 2 and one number of value 0.5. Next, if we have n equals 3, then we have 2 as well as 2 different 0.5. So if we look the pattern, we see that for the values of n, the number of 0.5 will be n minus 1. So function of 1 1, it says, we can say in this way that 2 plus 1 minus 1 1, that means 100. There are 100 values of 0.5 there. So it becomes 2 plus 100 multiplied by 0.5 equals 2 plus 50 and equals 52. So our answer is D, 52. I hope we all enjoy these three kind of questions and you can learn something from us. So that's all for now. Thank you so much for watching this video. See you soon. Bye.